Welcome to Upstack America's IT training programs. My name is Bob and I'm the IT training lead for Upstack America. Today's training is on data science and specifically on artificial intelligence and machine learning. Our trainer will take us through today's session is Paul DeBacker. Paul is a data scientist with outstanding work experience managing digital transformation projects on artificial intelligence and machine learning. He also holds extensive experience as a solution architect for robotics process automation, and also he has experience as a developer for robotics process automation. Paul holds a Master of Science in Artificial Intelligence and Machine Learning from the University of Texas in Austin. He also holds a first-class honors Bachelor of Technology degree from Anna University, Chennai. Thank you for watching and we hope you will enjoy the training.
Last week we did look into certain basics of statistics, right? We spoke about a lot of measure of central tendency, measure of dispersion, right? So Kevin, just a quick recap, right? So if you could highlight what did we learn on the last session, few quick pointers.
Okay, so on a measure of tendency, we did the mean, mode, and median. Then we looked at the measure of dispersion. We looked at the range, then the IQR, the standard deviation, and the variance. We also looked at the coefficient of variation. We looked at which is the ratio of standard deviation to mean. We also looked at the normal distribution and what describes a normal distribution. We ended up with a 5-point summary, which is the smallest, the Q1, Q2, Q3, and the X large.
Right, right, right. Yep. So we spoke about something called as empirical rule as well, right? Which we call it as the 3 sigma rule. So we saw
Yeah.
that it approximates the variation of data in well-shaped or normal distribution. So we can express 68% of the data in a bell-shaped or a normal distribution with one standard deviation of its mean, which was mu plus minus 1 sigma, whereas we could describe 95% of the data with mu plus minus 2 sigma and 99.7% of the data into mu plus with the standard deviation of mean mu plus minus 3 sigma, right? And then we saw 5-point summary and how it is very easy with just one word called describe in Python that we can derive the 5-point summary of the entire data set, where we have x mean, x max, we have the first quartile range Q1, we have the median range Q2, and we have the third quartile Q3. This was our measure of dispersion. And then we also checked one coefficient of variation, which is nothing but ratio of standard deviation to mean, which is S by X bar for sample, and it is mu, sigma by mu for an entire population. Right. So today's week we're going to talk about a very, very important part of data. So till now what we have spoken about was pretty much into interpretation, you can say analyzing and collecting of data, right? But we know that statistics also deal with interpretation and data visualization or presentation. So today our session will be mostly into a portion of it called as data distribution. That means when we interpret the analysis, or how do we interpret an analysis from a statistical outcome, and also what are the ways that we can project or present those specific analysis that we get it from a statistical analysis. So the first thing that we want to talk for the day is something called as shapes of data distribution. So we have already known that the data can be represented into various shapes. We have spoken about binomial, Poisson, but the important one that we spoke about was normal distribution, right? Can you give a quick highlight of what did we speak on normal distribution? What exactly is a normal distribution? Or when can we call a data to be normally distributed?
Normal distribution is whereby the area under the curve is equals to 1. The Q2 is right in between the middle, and the values on the left is equal to the values on the
Absolutely.
right.
Absolutely.
Yeah.
Absolutely.
And has the
Right.
bell-shaped curve.
Yes, that's the main thing. That's the bell-shaped curve. So in shapes of distribution, what we want to see is that when a data set is graphed, okay, each point is arranged to produce dozens of different shapes, because when I graph a data set, I have multiple data points, numerous data points that gets represented. So when we saw a bell-shaped curve, so this bell-shaped curve is nothing but how it is getting formulated. I am having various data points that are getting plotted at a various junction, right? These are all my data points which are getting plotted, and whenever I connect my data points together, probably I get to see what is the curvature of my graph, or what is the formation of my graph, right? So this is how we get to see it. So generally what we are trying to say is data set is graphed, each data point is represented or is produced, has generally produces thousands of different shapes. Each shape can give us some visual insight or tells us what the data is exactly showing. So what does the visual appearance tell us? The first thing is, what is the spread out of the data? What is the spread out of the data? That means how dispersed is my data, whether it is very tightly or close dispersed, or whether it is widely dispersed. What is the spread, whether it is astringent or it's a widespread? Like we know that what it's the measure of dispersion, or what is the variability, or how scattered is my data. So if you see something, we will learn more about data scattering. So if a scatter plot is drawn, your data points are represented something like this. So these are all my data points which are in the mathematical space, and it is scattered. So it also shows me how the data is spread out. Next, we know it tells us where the mean lies. That means for standard deviation, we know for normal distribution, our mu is equal to 0, our mean is equal to 0, and standard deviation sigma is equal to 1. So we can see that mu is actually at a scale of 0 for normal distribution. So so when our graph is drawn, we can easily understand what's the mean and what's the range of the data set. We have already seen range. What is range? Range is nothing but x max minus x mean. So that gives us the range of the data. So what is my maximum, what is my minimum x value, and what is my maximum x value, we get to know, right? So these are the various insights that we understand when we talk about data distribution or shapes of data distribution being graphed. Now, these shapes of data distribution is actually divided into three parts. Okay, so if I say data distribution shape, it is actually divided into three parts. Okay, the first one we call it as based on number of peaks. Let's say we call it as NP. So how many peaks are having in my data is having in my graph? Based on that, we call it, we name it. So first of all, based on peaks, the first type that we know, so under number of peaks, we have different subdivisions, okay, or subcategories. What are those? First one is unimodal. So unimodal distribution is nothing but any distribution having only one node. So for example, if I have a graph which is only like this, or the graph is somewhat like this, or the graph word is somewhat like this, so only one portion of the graph exists. Okay, so it means I will have maximum of one peak in my graph, not more than that. So it will be a single peak where it can be like this, or it can be another peak where the graph is like this, or it can be another peak where the graph is like this, but there will be only one peak or one node at my data. So that means either this will be, see, it is all, these are all unimodal because I can have only one peak in my data. So a single peak can take on many shapes. So it can be of this, it can be of nature this, it can be of nature this. And most of the type of unimodal distribution is normal distribution. Why? Because unimodal distribution can have only one peak, and any peak with like this form will always fall under normal distribution. So even though if the graph is somewhat like this, okay, it's still a bell-shaped curve with a wide spread, right? the spread is more, but it's still a bell-shaped curve with a normal distribution. So unimodal means we have only one peak, and one peak unimodal generally, results to something called as normal distribution. Now, next ones we have under number of peaks is we call it as bimodal. So unimodal is means we have only one peak. Bimodal is very similar. We can have two peaks in our data. So if I plot my data set, like starting from a value, so it can have a graph like this. Another peak can be like this. So where I have two different peaks of my graph or data distribution, we call that as a bimodal graph, where or a bimodal data distribution. Okay, just give me one sec. This is what we call as bimodal, and multimodal means whenever I have multiple peaks in my graph. Okay, I can have a graph which is somewhat like this with a curve with a bell-shaped curvature, or I can have a multimodal curve where I have the graphs as bar graph. Okay, so let's say these are the bars that I'm having. Okay, and I'm having the data represented in a bar graph. So you can see I'm having one peak here, I'm having another peak here, I'm having another peak here. So if I represent it in a bell shape, how it would actually occur, it would start somewhere like this, it will go like this, right? From there it will again go like this, it will come like this, it will take this shape, it will go again like this, it will come here, 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 and it will come like this, right? So this is how the normal, if I wanted to plot it as a a normal distribution curve, my bar graph would be represented like this, where I can see that there is one peak here, there is one peak here which is increased, and there is another peak here which is down, because it's rise, it's again falling here. So multimodal graph is when you see your distribution is having multiple ups and downs, and that means you have more than three nodes, three or more than three nodes. So here if you see, I have one node. Okay, I have another node here, I have another node here, I have another node here. So three or more than three nodes. Okay, so all these distribution with more than three nodes, generally we call it as multi-model, right? Any questions on this, Kevin?
No.
Okay, good, right?
Yeah, I'm good.
Okay, so now based on so this one what we saw was something called as based on the number of peaks. So based on number of peaks, I can say whether it is unimodal, whether it is bimodal, or whether it is multimodal, or either it can be none of the three. Then what it can be, it has to be something called as uniform, right? So if a data set distribution has no clear peaks, that is the whole graph goes flat. That means, let's say this is the graph and it is completely flat like this. Okay, so in that case, we say that this distribution is something we call it as a normal distribution. Any questions?
No questions. I don't have questions, Paul.
Okay.
Paul, you're on mute.
Oh yeah, sorry, I think there's a network issue. Yeah, so this is what is a normal distribution curves look like. So uniform means I will not have any sort of a bell-shaped position, no ups and downs and no peaks. Okay, I'll have a graph which has one flat peak with one flat look. So it can be something like this, or it can be linear as well. I mean, it can be less spreaded as well, or it can be something like this, but it will be having one flat portion. So that's where we can say that the data is actually distributed, but it's uniform because it does not have any clear peaks or trend, and it goes flat with respect to the distribution that I am trying to plot. Okay, so there are four types that we have then seen. One is what, based on the number of peaks, we can say it can be either as unimodal, it can be a bimodal graph, okay, it can be a multi-modal graph, or if with no peaks, we can call it as something as uniform. So these are the four types that we got to know based on the number of peaks that my data distribution might have. Among those, we saw that the unimodal is what is very similar to something called as normal distribution, because we will have one peak which would represent my bell-shaped curve in terms of utilization. If I say the unimodal is very much resembling to my normal distribution of the data, right? Next, now we did talk a little bit about this on the last session, that we can now see, we'll see in depth then, in detail. So in terms of symmetricity, okay, how can we divide our data? So generally it is, we generally take it as symmetric or non-symmetric. Either it is symmetric or not symmetric, right? So what is symmetric? So when I see that I have a distribution which is plotted, and my distribution, when seen with respect to my mean, symmetric means I'll have a normal distribution bell curve where my mean mu will be at equal to 0. So with respect to my mean, I should have something called as mirror image on either side. Mirror image on either side means with respect to my mean at equal to 0, my this portion of the graph is nothing but an exact mirror image of this portion. So with respect to my mean, the total area under the curve is always 1, but it's like dividing it into half. Equally divided is what is symmetric. That means one portion is identical or a mirror image of the another portion. That means dividing it into equal part. This portion is my 50% and this portion is my 50%. So that is what is called as a data distribution with respect to symmetricity or symmetric data distribution. Now, what will happen when it is not symmetric? Then we come into something called as skewness. And very, very important in machine learning to understand your data attribute pattern. If your majority of your data will not be symmetric. Let's say I give you any random data set. We will see one of the examples today in one of the exercise. So most of your data sets that you get for analysis may not be symmetric. Let's say there will be an 80% chance that your data is not symmetric, because every time if you get a symmetric data, that means your data is having a normal distribution, your analysis is very easy. But that's not the case, right? That's not the case, or that's not what we generally get in a real-time data set. So we will see that when the data is not symmetric, that means when we plot it with a normal distribution, the mirror image is not happening. That means my mean is not equal to 0, right? My sigma or standard deviation is not equal to then 1. There might be deviations to it. With respect to this, when my mean is not equal to 0 and my standard deviation is not equal to 1, my data distribution gets shifted either to the left, sorry, to the right, or either to the left, correct? It has to shift. This peak has to shift either this side or that side, because if it is at the middle, that means at a mean equal to 0, my data will be normally distributed. I will have a symmetricity. But if it is not similar, this peak will never lie here. It will either shift to this side or either it will be shifting to this side based on the nature of my data. So that is what we call it as skewness. So shapes of distribution can differ in skewness. These are not symmetric. Instead, however, instead have more points plotted on one side of the mean than on the other side. That's what I said. So if it is symmetric, get this point. Okay, it's very, very important to understand a data distribution later on. So if my data distribution is symmetric, I'll say directly mean is equal to 0. But if it is not symmetric, then instead what will happen? Majority of my plots will be at the one side of the mean. That's what I said. So then if my data is not symmetric, then this peak will get shifted either to the right or to the left. That means majority of my points are now rightly falling here in the middle. But it is saying that if you have a skewness, one side of the mean than the other. That means if it is pushed to the left side, most data points will fall on the left. If it is pushed on the right side, majority of the data points will be plotted on the right side. And this will be a skew data. So it causes a long tail either to the positive or the negative side. So this side we call it as a positive scale. This side we call it as a negative scale, right? Now, what is this long tail? So let's see. Now, when I have a graph which is normally distributed, see the graph appears like this. That means it is symmetric with respect to my mean. I have an equal portion at both sides. Now, when I have a data which is either maximum point is either at one side, then how the graph will look like? So either the graph will be somewhat like this, okay? Okay, see from middle of the peak, now my peak has shifted. So it causes a long tail either in the positive or the negative direction. So since my point has majority of the point has shifted to this side, I am able, the data is creating a long tail towards the positive side for this case. What could be the other case? The other case would be that the data is somewhat pushed like this. So it is pushed towards the positive side of the scale. So my long tail is getting created here. Okay. So that means whenever my data is not symmetric, it can be either pushed to the left side of the scale or to the right side of the scale. So I can have a long tail towards the positive direction, or I can have a long tail towards the negative direction. This is what is called as skewness in the data. Okay. Now let's see the distributions. So now now we know that towards the positive direction, I can have a skewness which is like this way. So my peak would be here. Towards the negative direction, if I have my skewness, this is the long tail towards negative direction, right? And this is the long tail towards my positive direction. This is my data with respect to symmetricity normal curve. So now see the difference. This graph tells you a lot of information, lot. So when I have a normal curve represented with symmetric distribution, my mean, median, and mode is all at the one place and is equal to 0, right? That's the definition of a normal distribution. The moment my data shift towards the towards the left, negative direction, see, my mean is getting shifted, my median is getting shifted, my mode is getting shifted. And this type of data is called as negatively skewed data, or we call it as left skewed, because the tail is approaching towards your left hand side. Okay, or whenever you see that this peak is shifted towards the right, that means your tail is longer towards the left side. We call it as a negatively skewed data or left skewed. If you see data scientists or machine learning engineers talking, they will, if about a data, let's say somebody is asking, okay, so I've given you this data, so what's the skewness? So somebody will reply, hey, I see, this data is towards the left side. It looks like to be a left skewed data to me. Or, somebody will say, yeah, it's not normally distributed. I see, it's positively skewed. So the moment you hear this word called positively skewed, you should get this image in your mind, that this is what they're talking about. When you hear the word negatively skewed, you should get this graph in your mind, that they are talking about this. So the data is actually now looking like this. Symmetric, we know. Now, when I say it's positively skewed, that means my peak is shifted towards the left, right? My long tail is moved towards the positive direction of the right side. Now see, my mode remains at the same place. My median gets shifted, my mean gets shifted towards the positive direction, and I'm able to create a long tail. So this is what is called as positively skewed, or we call it as right skewed data. This is left, negative, this is positive, this is right. So very, very, very important concept in machine learning, data science and statistics. Wherever you go, any data you talk about, any graph that you draw to understand or explain your data to somebody, this is the way you go. This is the way you go. This will tell you, now based on this, you will machine learning, when we learn about various machine learning approaches, now based on this distribution, you will decide which step to apply, which machine learning algorithm to apply, or what could be your next step in your machine learning building, model building exercise. It's very, very important. Any question on this, Kevin?
No. No question.
Okay, it's clear to you, right? What do I mean by right skewed or positively skewed? What do I mean by left skewed or negatively skewed? Correct?
Yeah, that's clear.
Okay, so if I give you a data, okay, and I say that your data is not symmetric around Q1 and Q2, Q1 and Q3, what will you understand?
If the data is not symmetric, means it's skewed.
Yes. So if I say not symmetric around Q1 and Q3, that means you will feel either it will be this or it will be this, right?
Right.
That means either your data would be negatively skewed or a left skewed data, or it will be a positively skewed or a right skewed data. Okay. So that's how those various statements might appear. So you should be able to relate and find what they're exactly talking. So this is where we see again same thing. So there we saw it as a negative and positive. Here we are saying that when my tail is towards the left, I'll say this is left skewed. This is symmetric with respect to my mean. See Q1, Q2 and Q3. Okay, and this is right skewed where my tail is towards the positive side of the graph. Okay, and this is where my Q1, Q2 and Q3 lies. We will talk about these images later. You might not be able to understand now. These are called as box plot. And we will read about this when we do data visualization. So this is one of the important approach or one of the most important graphical representation in machine learning called as box plot. We will in data visualization piece, we will be learning about this. Now, let's see what could be, all the possible data variations that I can have, right? With respect to my so with respect to my data distribution, what could be the various shapes that I can have, right? So this is my normal distribution. This is my negatively skewed where I am having a tail towards this side. This is my positively skewed where my tail is towards this side. This is a bimodal because I'm having a peak here. So this is one peak, it is little down and I have another peak. This is, we don't get much. This is called as J-shaped graph, kind of a parabola kind of a shape. This is called as inverted U shape. These two are very rare. We don't get it much. So we'll ignore this for time being. And this is what is a rectangular shape, or you can say uniform, where your graph doesn't have any peak and goes very flat with respect to your axis, right? So this could be all the various distribution that we look like, right? Normal, remember these terms, or symmetric, negatively skewed or left skewed, positively skewed or right skewed, bimodal, unimodal is also negative, normal distribution, and uniform is nothing but flat with respect to your axis. So these are all the various data distributions when we talk about understanding data or its pattern or its a hidden pattern or its features from a graphical point of view or from a graphical standpoint, right? So any questions on this piece before we move on to the next?
No. No question.
Okay. Right. So, and one more thing, I'll just give you a hint now. We will be learning about this later. So let's say I have a graph plotted. Okay. So remember, whenever the graph is having a tail towards the positive direction, what do we call this? We call this as right skewed. Whenever the graph is having a tail towards the negative right direction, that means from the left, we call it as left skewed or right skewed. Now, based on this, we define there is also something called as correlation of the data. Okay, or we call it as correlation of data points. So that means if I plot one graph, one data point to the other, are the data points correlated to each other? Okay, so we will read about it in inferential statistics, but just to understand for the negative right skewed and left skewed. So whenever, let's say, I don't take this graph, I have a graph, okay, and I'm plotting my graph data something like this. Okay, the data points are like this. Okay, another graph, let's say I'm plotting, where my data points are falling like this. Okay, now can you just guess and tell me what could be the difference between this graph and this graph? What can we call, what sort of a correlation can this be, and what sort of a correlation can this be? Any guess?
I think based on how the data points are, one's going to be positive, the other one's going to be negative.
Absolutely, that's a bang on answer. So, when we talk about data correlation, okay, generally what happens is my data points, let me just draw it in a little more clear. So, when you have a graph, okay, and your data points are falling like this, which are in kind of somewhat in a linear mode, okay, somewhat in a linear mode, but is approaching towards this side, towards the positive scale. Here we call the data sets, data points are positively correlated to each other. Okay. Similarly, when I draw a graph of my data points and my data points are approached or represented somewhat like this. Okay. These are all my data points. Okay, which is kind of inclined or approaching towards the negative scale of the graph. We call these data points are negatively correlated. So based on symmetric analysis or skewness, we can define the data. Also, based on the data distribution, if we say can there be any relation between those data points, we say the term called is correlation, where if the data points are inclined towards my positive direction of the scale, I say these are positively correlated, whereas something inclined towards this side, we say the data are negatively correlated. And if I, let's say, have something graph like this, where, okay, let's say I have a graph where my data points are like this. It's random and it's scattered. So here it's very tough for you to define any correlation. So here either it goes for no correlation or it can have multiple relation when your data points appear like this. So we will be reading about the correlations also. Okay, so just to give you a hint so that you can relate towards your positively skewed or negatively skewed, and also your positive correlation and the negative correlation of the data, right? Any questions on this, Kevin?
No.
So then, okay, so with this, we are pretty much at the end of our descriptive statistics portion. Okay, so we're going to deal with a business problem, or a live data set. We're going to see how a data set appears. Okay, and if we are given a specific business problem, and we are not going to apply any machine learning because we haven't learned anything yet, right? So let's say you are a statistician, you have been given a business data, right? So with respect to your business data that is given, you are being asked by your company or your organization to do some analytic descriptive statistical analysis to give some insight what this data is telling about. So descriptive statistics is something, what do we know about the definition? We will have the history of the record of historical data. That means things that have already appeared, right? And inferential statistics means when we predict something is going to happen like this or that. So it's a very common use case that we see on descriptive statistics. So we will have a business problem, we have defined the solution approach, and then we're going to see the data distribution as well, and we're going to go to the Jupyter notebook as well. So what is the business problem statement that we have? So we have a data of a cardio fitness case study for our descriptive statistics. So what is this cardio fitness? So probably let's say you are the owner of a cardio fitness center and you have your various customers or various users who have registered to your fitness or your gym, right? And you have a data of all your enrolled customers, right? Now you as a gym or a fitness center have decided to analyze your customers data or your users data and see who are doing well or who are not doing well, who is doing what, so that you can come out with some insights that whether it is important for you to give. So it is you are able to decide that do you need to give any suggestion to any of your customers, right? Which customer is doing bad, which customer is doing good, right? Or how overall your fitness center is doing, how you do with the basic descriptive statistics. So it's a data set which says the market, it's a data set from a market research team of a fitness study center called as AdRight. Okay. So the market research team at AdRight is assigned the task to identify the profile of the typical customer for each treadmill product offered by the cardio fitness center. So this cardio fitness center has offered their customers a treadmill product to buy. Okay. The market research team decides to investigate whether there are differences across the product lines with respect to the customer characteristics. So different treadmill products that they have, whether these products are pretty much in line or matching with the customer characteristics of that specific cardio fitness center. The team describes to collect data on individuals who purchased a treadmill at a cardio fitness retail store during the previous 3 months. That means we have historical data of 3 months of the customers who have bought a treadmill from of some of a product, treadmill of any product from this cardio fitness center. The data are stored in a CSV file. So we have a comma separated file. So are you clear with the business statement? Because generally your problem statements in any machine learning will come like this. You will have a description of your business problem statement. You have to define a solution approach. And if you see the last slide, here I have something called as the data. So this is how the data is. We will see about this. So let's go back to that. So are you clear with the problem statement, what they have asked us to do?
Yes.
All right. So generally, always remember one thing. In machine learning or any statistical website, when you are given a data, just always check how long is the data duration. What do I mean by that? That means for how longer, or for how many days or months or weeks they have given you the data. If I give you 2 years historical data and ask you to do a machine learning exercise, your model will be, let's say, giving you a 90% accuracy. If I give you 6 months data and ask you to do a machine learning model exercise, your model will be, it will be very tough for your model to learn. Your accuracy might be 70%. Why? The more you get historical data, the more it is better for any statistical or machine learning exercise. Remember this point very much. It's a thumb rule. That's the Bible. So ensure as much as data you get. So here we have got minimum 3 months of data based on this use case. If they give me 15 days data, I will hardly have any outcome about it, right? There will be hardly any pattern, because to understand a complex pattern, you need large data sets. Then only you can see the spread of the data. What is your variance of the data? That's where your machine learning exercise is all about, which you cannot compute by yourself, right? So what is our solution approach? To perform descriptive analytics to create a customer profile for each cardio fitness treadmill product line. So that is our descriptive analytics would be our solution approach. No machine learning, straightforward analytics of statistical analytics to create a profile to see which to see for each cardio fitness product line for each of our customers. Now, let's see what is the next slide. Now, it is saying, I have to minimize this slide. Okay, so it is saying about the data preparation. Now, the team identifies the following customer variables to study. So this is the data set which I have. This is my cardio fitness data 1. It's a CSV format file. So see, what are the information that I have got from the fitness center about their customer. So we will see this. Let's review this. So the team identifies the following customer variables to study. So first, the data they have given has a product code, which is like the various treadmill code. So 195 is a type of a treadmill. Okay. There should be other 498 is a type of a treadmill. So it's all repeated. So that means these are my product or treadmill code. Like it's a, just you can think of it as a product code. Every company has their own product number, right? So these are the TM195, 498. These are various product codes. So I have 3 types of treadmills actually: 195, 498, and 798. Okay. Then the data has, what I have is something called as gender. So for this product group, I have a customer who is male, okay, whose age is 18 years, whose education is something they have denoted is at 14, 15. Okay, let's see, it might not be useful for us. Marital status, usage. So what is usage? Okay, relationship status, education, age. Now we'll see what the usage is all about. Average number of times the customer plans to use the treadmill each week. So usage means how many average, on an average, how many times the customer has planned to use this treadmill. So every row is one individual customer level data. Let's say this is Kevin, this is Paul, this is Bob, this is somebody else. So if this is me, so I am having a product code of T195. I'm 18 years old. My gender is male. My education status is 14. That might not be necessary for us in a gym data. They would have mapped some education with some code. 14 is higher secondary. 15 is college pass out. For 13 is PhD, something like that. We don't know that piece. We just receive the data in this format. And anyways, education might not have an impact to our gym. So you always might have data columns which would not be relevant to your exercise. So in those cases, you can ignore them. So here, obviously, by layman's understanding, we still think an education with respect to my fitness or buying a product from a gym might not be a relevant attribute to look at. Marital status, we are not sure. Education is definitely, you can say I don't want it. Marital status, you are not sure whether marital status is relating to any of these insights. But yes, marital status might be. What can be the insights? If you see marital status, it is single, partnered, or married, something like that. So let's see what are the different values. It is partnered or single. So marital status is a good insight, where I can use and say that what sort of customers are buying products more, whether it is the single customers who are buying my treadmill more, or whether it is the married or the partnered people who are buying our treadmill more. That's a good insight to understand my sales, to understand my data pattern. So this is how you have to take a raw data when you are given, you have to analyze. Age is a very good distribution. I can understand within what range to what range of people are buying my treadmill more? Obviously an 80 years old guy, a person will not buy a treadmill, right? Whereas aged people aged between 18 to 40 or 50 can buy my treadmill more. So with this age column I can find an exact range of people who are buying my treadmill, so or who has bought more treadmills, so I can target age of range, age group of people. Whether gender, male people are buying, customers are buying more, or female customers, again a very good insight. Education, I don't find it very relevant here, because whether you are college grad or you are university grad or you are a PhD scholar doesn't make sense to me. Yes, marital status matters, because single people might be, let's say your data might say that people who are single are more trendy towards fitness, whereas people married or partnered are, partially trendy towards fitness. Usage, how many times do they aspire to use this treadmill in a week? 2, 3, 4, 5, 6. These are the usage terms. What is the fitness definition? Fitness is saying, and self-rated fitness on a scale of 1 to 5. 1 is poor and 5 is excellent. So this customer have rated themselves based on their fitness scale. 1 is very poor and 5 is the excellent. So somebody who has rated 4 is is a fit guy or a lady. Somebody who has rated himself or herself 2, her fitness level is not that good. So this column tells me about the fitness of a specific customer. This is again a very good insight. I can easily say, now what I can relate to is, I can say what sort of insights I can find. If I relate this to column, fitness and marital status, I can get a drastic business insight. So what is my fitness level across my married customers and my fitness level across my single or single customers? That's a very good insight for me. This is where your hidden data, this is what is your analytics. I take various attributes or various columns and try to find out what these columns are telling me. Okay, so then what is the income level? Absolutely, income is again a very good factor here. Average annual household income, because people with having less income might not be able to afford of buying a treadmill, right? So it is very, very important that I also have an income level data to understand what is the minimum income level of the customers who can afford these products to buy these products from me. The last one is miles. What is miles? Average number of miles the customer expects to walk or run each week. So this is the usage, average number the user is trying to use the treadmill. They have rated themselves on a fitness scale of 1 to 5. This is their income, and this is the miles they are planning to run or walk or use the treadmill for on a weekly basis. Okay, so this is, so whenever I give you a data, it is very important that with respect to the data you have a description also of each and every column. See, I was not aware what is this fitness column is all about, so I went and read the data description. So this is called as domain knowledge. So a guy who is a gym expert would always know that what this fitness data is all about, right? Somebody who is a sales guy, if let's say if I have a price column, somebody who has a sales guy will be easily able to say what is the minimum price of these products, or if TM195 is a treadmill, what is the average price by which a customer is buying, right? So this is how your data set description would always be given to you. For this you need a domain knowledge. That's why machine learning or statistical analysis is very much dependent on your business operations team, right? Because any data that you get, these are the business guys who are very close to the data, who works with the data day in and day out. They are the ones who's going to explain you the description of the data. So that's how we get it. And then we see the data. Then what are the analysis I can do? This is what is on my plate as a machine learning engineer or a data scientist guy, right? So any questions on this data, Kevin? Do you have any questions? Or if I say, what other insights you think you can find out from this data? And if you give me, if you have to give me some pointers.
No, just like you said, the age, income, and relationship status will determine a lot how much somebody exercises or how much they're going to spend on a gym. So,
Right.
yeah, given
Anything
that,
else combining these columns you can think can be found out which I haven't mentioned? Obviously there are, I mean, I still can say two or three more analysis that I can find out. I just want you to apply your brain and see, because this is the first problem statement real time we are dealing, right? So I want you to open up and have an analytical approach, so that your thought process also diverses.
hmm,
Take a minute, look into the data. See, never hurry yourself with respect to learning the data. It is never, even the top data scientists can never understand the data probably at a first look. Here it's a very small data. How much length? I have only 180 records of data. And there are only 1, 2, 3, 4, 5, 6 to 7, 7 to 8 columns. It's a very minimal data with respect to our first exercise. You might have a data which is having 1 million records, or 2 million records, right? So in that case your analysis becomes more diversified. So then you have to apply, you might have 5 more columns here, you know so you have to understand in this case the data very well. So
I'm trying to think here.
I'll give you three things.
Okay.
So how can you relate this income with any of these columns and find out anything else? Just think of it. So this income level data, which other data column if I take, I can able to, I would be able to find a proper analysis. Let's say
Okay.
income is one variant, right?
If, yeah, if you relate the income and the education in years, I think the more you educated, the more you're going to earn. And the age, I think,
Absolutely. But do you
oh,
think if I map income with education, it's gonna give me a valuable business outcome for my fitness center?
I believe so. Because I think if your household income is higher, which will might be reflected by the elder or people who have more education, it would
Okay.
show the sales would come from more people with educational years due to their high income.
Okay. Yeah, that could be one. Another thing is we can also associate income to the gender column as well, right? And see who
Yeah,
in this data, whether it's the male gender who are having higher income or it's the female gender who are having higher income, right?
true.
Then, so remember these terms, we will learn about it later. So when I look at one specific attribute and find something, this is called as univariate. One is uni. When I combine two columns and try to find out something, we call it as bivariate analysis, because bi means two. When I combine more than two columns and do something, we call it as multivariate analysis. Just like what we learned, unimodal, bimodal, multimodal, right? Here we call it as univariate, bivariate, and multivariate analysis. So this is how we generally do. So anyways, I'll also give you this data set, okay, along with the module, so you can go ahead and also explore. So let's jump on to the Jupyter notebook quickly and see that how do we generally approach. We will not go much deeper today, because to do this exercise we have to learn a lot of other stuffs, okay, from a visualization standpoints as well. But till what till what we have learned today with respect to the theory portions, we will be analyzing that today. So this data is given to you. So whenever you are utilizing your Jupyter notebook, it's easy that you can load your Excel data into a Jupyter notebook. So this is my Excel data set. So everything I'm loading it into a pandas data frame. So my data is appearing now like this, so it is much more easier for me, right? So what I have done, I have first imported all the required libraries. So I have
Hey,
imported
Bob,
NumPy. Yes, yeah.
could you share that screen?
Oh, okay. Is it not visible? Give me a sec. Okay, my bad. Okay, fine. So you are able to see the Excel sheet, right?
No, I'm seeing the Jupyter screen.
No, did you see this sheet before?
No, I didn't see it. Now it's the first time I'm seeing it.
Ah, oh, my bad then, probably. Okay. So this is what I was talking about. Okay. Oh, you should have told me that, the Excel is not visible. Okay, my bad. So this is how the data looks like. Okay. This is how
Okay.
the data looks like. So this is the description of the data that I was talking, right? So I have a product purchased with three different things: gender, age, education, relationship status, annual income, average number of times the customer plans to use the treadmill, average number of miles the customer expects to walk, and self-rated fitness scale. So this is my data, which is in an Excel file. Okay. So if I see what's the length of my data, I have around 181 records with how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 different columns. So this is my product information, which I have seen here. I see that there can be three different products. Okay, this is the age, this is the gender of the customer, this is the education level. What is the education level? Oh, education in years. Oh, okay. So it says how many years of education does a user has. So it starts from 12 years and reaches to 21 years. So that's the number of years an education approach is having. Then marital status, single person, or partnered. Usage, how many times and averagely you aspire to use this treadmill in a week. Fitness score by individual customers at a scale of 1 to 5. This is their income in dollars, annual household income, and this is the miles they aspire to run on a weekly basis on an average. So this is the data that is given to me, which is coming from where? This is from an EdRight Fitness Study Center, where they want to do a descriptive analytics to analyze the customer profile for each cardio fitness treadmill product that they have sold for a period of last 3 months. We are not going to do any prescriptive, we are not going to predict anything. It's just the existing data, historically, what has happened to the business we have, and we are going to analyze the same. So now if I was not even not able to see the Excel. So now do you see or try to find if you have any questions or any other things that you could relate with respect to these columns?
Well, the other thing I could look at is the usage
Hmm? Okay.
related to gender.
Yes. So you can relate usage related to gender, and you can take these three together as well. So if we do a bivariate, we will take usage versus gender. But if I want to do a multivariate analysis, I'll take age, gender, and usage, all three together as well. And I
Okay.
can say that among the genders of male and female of different age group, what is the usage level? Make sense?
Yeah.
Right. So let's jump on to the Jupyter notebook. Okay. So first task for me is to open up the required libraries in Python. So import NumPy and import pandas as PD. So ensure if you don't keep the file in the same folder where your NumPy notebook is, you have to give the absolute path. So I have kept it on the same folder where my notebook is. So I'm just able to directly load this. So my data is equal to, it's a CSV file. It's the file format is comma separated. So I'm using pd.read underscore CSV, not pd.read underscore Excel. So if it's a CSV, always go with read underscore CSV. If it is XLSX or something, then go with pd.read underscore Excel. Okay. Now, this is where my data is loaded to a data frame. I'm naming it as my data. Then I'm saying my data.head. That means head will show me top top 5 rows of the data set. So this is the same data which got loaded here. You can match it. So first one is T95, age 18, male, education 14. So if I move here, T8, 19, 8, same data, right? So I have now converted my entire Excel analysis data into a Python notebook. This is how your machine learning or statistical analysis work. Okay, so you have to load the data in a Python data frame. Now, straightforward, what I'm trying to do is I see that there are a lot of values here. So I'm trying to identify the 5-point summary, which we have already learned. So I'm saying my data.describe include is equal to all is a parameter. Okay. So what happens is describe by default takes only numerical values. Now in machine learning, we have two concepts. Okay. Remember, data, any data that you get in an Excel or anything for machine learning can be of two types. One, it can be numerical data, or we call it as continuous, okay, where it is nothing but numbers. Another, it can be categorical data. Categorical data means textual data. Okay, so these are the two norms you have to remember in any machine learning related exercise. So if I look at this data here, so I have a combination of categorical data and numerical data. So this gender is actually male, female. These are categorical because these are textual data. Marital status, single partnered is a categorical data. This one, product, is that categorical data. Age, it's a continuous data, it's in numbers. Education, it's a categorical continuous data. Usage, fitness, miles, income, these are all my numerical or continuous data. Okay, so I'm saying if I don't include all, it will by default take only the numerical columns. Okay, so I'm saying include all. So it for the product, I don't need this, so it is giving me the 5-point summary. So now if I come to the age column, okay, so let's see the 5-point summary from here. So what is the mean of the 5-point summary? My minimum age is 28.7. That means 28.7 is the mean age, average age in my customer record. Standard deviation of age is 6.9. What is the minimum age value? 18. 25 percentile age, that means this is my Q1, is 24. What is the Q2? Quartile 50 percentile of range is 26. This is my Q2. And 75%, which is my Q3, is 33. So I have my mean, I have the standard deviation, I have the minimum value, I have 25 percentile of age, 50 percentile of age, 75 percentile of age, maximum value of maximum is 50. 50 years above, I don't have anything in the data, right? So this is how the customer age is appearing. How is the gender appearing? Obviously, gender is appearing only two different types of gender. So that's why unique values are two. Whether it will be a male or female, we definitely know. Product unique value is 3. We know that only 3 types of product is there, among which the top product is TM195. That means this is the one which is sold maximum, or this is the product which is sold 80 times. Okay. Then age, we don't have anything on this. Gender, what we are seeing, two different values. Male, 104 people are male. Okay. Education. So education is actually giving me some value, but it will not make sense to me because these are number of years that are into my data. So we cannot, though I'm getting a standard deviation, mean and everything, we have to look it in a different way. Marital status, again, it's a categorical column. So either it's single or partnered. My data is having 107 people partnered. So most people are partnered here. So that means majority of my data analysis is data of, or my existing customers are either married or partnered. That's what it is, right? See, these are the small insights I'm able to get from my business data, right? Okay, if I look into the fitness, it's a numerical column. So I know what is the average fitness level. If I see average usage, everyone is using it for minimum 3.4 weeks. Average fitness of every customer is 3.3, and average income of all the customer is $53719, and average miles that everybody is trying to run is 103, right? So these are the various insights that I get from just one word called as describe. and I can go and tell my business firm that, okay, from the data, your this many customers are male, this many are female, your top customers are buying 195 product, you have already sold 80, 195 treadmill, your male customers are the ones which are buying it, your partnered customers are 107 who are more active, or are buying more compared to your single. Like this, I can bring statistical insights from the data, and I can go and take business action. So this is pure play statistics, right? Okay. Next, finding data attributes. So my data is the data frame where I've loaded the data. So when I say my data.info, I get to see the various data types of each and every column. So see, product, it's an object column in data frame. That means it is a categorical data. Age is integer 64, that means numerical. Gender categorical, that's why it is appearing as object. Education is again a continuous or numerical int 64. Marital status is again object. Usage, fitness, income, miles, all these four are my category numerical values, so it is coming as integer 64. So info gives me the various data types of the various columns that I have in the data. Now, this is how the visualization or the graph appears. We will learn about these libraries individually, but I'm just trying to explain you for the time being. So Matplotlib is one of the libraries that we use for generating graphs in Python. Okay, like pandas is used to read data and store it in a data frame. Matplotlib is the package in Python which we use for data science related, data visualization related package. So Matplotlib allows me to draw graphs with my data. Okay. So what I've done here is I'm saying import matplotlib.pyplot as PLT. This is one of the packages that I'm importing. This graphs I'm drawing is called as histogram. Okay. Histogram is a type of a bar graph that we generate. So I'm saying my data.hist, that means I'm asking to draw a histogram for me. This is a figure size I'm defining 20 by 30. That means this frame. Okay, within this is my graph. So this is a by default size that I'm asking. So I'm saying use this library, give me a histogram of this data where my data is having all the data of my fitness, right? With the figure size 20, 30. Plt.show is the command to appear these graphs on the notebook. Okay. Now, if we see each and every data distribution, let's talk about the age graph. Now, see how the age graph is appearing. If I draw a bell-shaped curve from here, how the curve will look like? The bell-shaped curve would be somewhat like this. So can you tell me whether it is symmetric or not?
Well, it is not symmetric.
Okay. So what form of data distribution it falls into?
That would be positively skewed.
Absolutely. So that means my age column is rightly skewed because the long tail is towards the right. Now you understand? So whenever I have any raw data, any business data, how can I get it into a Python notebook and see what the data is telling me? Whatever we have learned in the theory, we are applying it in a practical now, hands-on, right? So this is how I can tell, okay, my age column is rightly skewed, because whenever you see, as per the central tendency, maximum data might fall in here. So that means your graph will always be inclined with the tail towards the right. Unless and until your central tendency as per this, your data falls here, you will never get a symmetric graph, right? Next, education. Education is not showing me probably any normal distribution. It is kind of a multi-model, because if I draw it like this, it will have multiple peaks, right? Multiple peaks are there. So it is not showing me a normal, but it's a multi-model distribution, I can say, right? Next, I'll just clear them. Yeah. Next is my miles column. And always remember, you can plot graphs only for numerical columns. You can never plot graphs for categorical columns unless you convert the categories into numbers. That also we will learn later. Okay. So what is my next numerical column is my miles. Again, if I see, I have just supplied this data in an Excel to Python in a data frame. Python is self-sufficient enough to plot this graph automatically for me. So now when it is plotting, then if I see the graph and I try to draw it into a bell-shaped curve, I see again it is having a tail towards the right. So even the miles is a rightly skewed data for me. Usage, again, not showing any proper pattern, again a multi-model distribution, not having a normal distribution kind of a curve. So see, that's what I said. So your data might never be symmetric always. Till now we have analyzed 4 columns and none of them were symmetric. So it's very rare that you get a symmetric data, because symmetric means your data needs to be mirrored, mu equal to 0, which is very, very difficult to get. Now if we analyze the fitness, see, it's like individual. There's no pattern based on the values of the fitness level, because these are raw numbers and these are nothing but counts. So that's why I can see a bar graph of 3 point anything between 3.3, right? If you go back at the top, you will see what is the average fitness level. The average fitness is 3.3 here. See, even the graph that is drawn is justifying that. So 3.0, 3.5, maximum value is here at a 3.3. So that means average is 3.3 for me. Then if I see the income level, it is also not having not a proper distribution, I can say, but somewhat rightly skewed, you can still tell it. So if I draw it like this, still slightly rightly skewed, but there are multiple ups and downs. So you do not have a specific, it's not a typical rightly skewed pattern. Somewhat rightly skewed, because I can see a rightly skewed distribution there. But whereas if I look into my age and I look into my miles, it properly shows me that the data is rightly skewed, right? So with this, I'm going to stop, because the next portions we have to learn the theory part first for further analysis. So what I'm going to do is I'm going to give you this data set along with the study material. I want you to read this in a pandas data frame by yourself and come up with the insights that I can generate. If you are able to do it in pandas and show me, it's absolutely fine. Else, I want you to write it in a statement. So, right, in a Jupyter notebook also, you can write texts, right? So how do you write text in a Jupyter notebook? So let's say you load the data. Next, I want to write a text here. I don't want a code. So change this code to something called as markdown, and then whatever you write, this becomes as text. So those will not be executed when you run the sheet. So 5-point summary, see this cell I have converted into a markdown. So that's why this cells will not be executed as a part of the code. Okay, so I'll give you this sheet. I'll give you this. So try to do this again. I'll not give you this now. I want you to import this, do a 5-point summary info, visualization. Yes, if you want, take this graph. I'll give you this piece. Okay, and generate these graphs and give me other insights that you think you can generate from this. If you are able to do it in a pandas data frame, it's great. Else just give me in statements and we will review it tomorrow. Okay. Right. I think yes. With this, this is what I have for today. Any questions on today's session, Kevin?
Are you going to upload that to the Upstack member login?
Oh yes, I'll push it to. I'll give it to Bob. He will upload it into the materials column.
All right.
Or in the portal, you can download it from there. Okay.
Okay.